Well, hello, everybody. Thank you, Dr. Luis, for the presentation. So, as Dr. Luis said, I'm from Argentina, not from North Dakota. I just work there, but my accent is kind of weird, so sorry about that in advance. So I'm going to talk about spacesuits and give you a little bit of an historical background information about how spacesuits develop. And sometimes I think that the name spacesuits is a kind of a misnomer because, you know, a suit is something that not necessarily is a useful thing. You have a tie that doesn't serve any particular purpose, and a spacesuit is something totally different. That's why I like the scaphandra name that the Russians use for their spacesuits. I see it as something a lot more complex than just a suit. I normally say that to me is a miniaturized spacecraft. It's something that have to provide you with all the elements that spacecraft does, and also give you mobility and the ability to work on the space or a planetary environment. So here you see some of the examples of what we understand for a spacesuit today, which is well, there's a Russian Sokol suit on the left, and the center, the shuttle EMU, the space shuttle and space station suit used today by U.S. astronauts, and Russian prototype for a planetary suit. And this is just some of pictures of historical and current spacesuits, both U.S. Soviet Union / Russia, and lately the Chinese Feitian spacesuit. Now, as I was saying today, not always a spacesuit looked to the designers in the way it looks right now. We can recognize the helmet, the portable life support system in the back, etc. But it wasn't always that way. And talking about the beginnings of spacesuit, of protective suit research, the first attempts were made in the early 19th century for what is called hyperbaric pressures, meaning in this case underwater. And probably Jules Verne was the first one to consider the use of suit to protect humans for a reduced barometric pressure, meaning more altitude, in 1872. Now, the first I can say academic approach to the topic was done by Konstantin Tsiolkovsky in Russia, and it's interesting that he, in his drawings, he already saw that need for the backpack where your consumables will be stored, your helmet, and he even devised an airlock design that years later was used by the Volga Soviet spacecraft to do their first spacewalk. And like many other things in the space, the beginning of many technologies started with aviation. And the first works in that sense took place in France and the United States between 1910 and 1918 with the first protective suits that were going to be used for open cockpit pilots to go higher and higher. And of course, if I'm not wrong, the Wiley post suit was used at first in the 30s. It's here at the Air and Space Museum. It's the first practical example of that. And also there were all sorts of very curious, odd-looking suits. We have on the left there is an Italian model that it was all metal, and I love the wiper detail in the side because of course they were used for open cockpit airplanes, so you have to think about the rain. And there is a German, not very comfortable looking suit in there also for pilots, and some other models, a German one that looks like a knight's armor and some other designs. And of course all these kind of move forward in the 50s, where the first stratospheric flights, well, between the 30 and between Picard and later flights, we can see here the Volga 2 gondola, where
some other suits were used in the Soviet Union. So we can see here some of their models too. And of course, some of the suits that you can see here are not very kind of practically looking. Some of them are what they were called get me down soon, something like that, suits with a zipper and just one arm. But of course, you were not supposed to walk on those. But you can see that there was a trend of development that made them more and more practical. And of course, we have in the 50s the so-called partial pressure suits or capstan suits that were used in the U-2 flights and some later fighter pilot planes. But of course, not the suits first developed for space or thought for space were not anthropomorphical. That means human shaped. For example, this is a concept of what was called the bottle suit, what was thought by von Braun and his team as a suit that you just are inside a tiny spacecraft and you have to manipulate the arms through some kind of robotic arms. When we talk about the differences between space and why we want a spacesuit, I borrowed this NASA cartoon done in the 60s to explain to children why a spacesuit is necessary. And of course, you can see here, without a spacesuit, as the atmospheric pressure reduces, you start the ballooning up process, and then your blood will boil, and then you will have anoxia with this lack of oxygen, and if in a few seconds you will be unconscious, and something else will happen. So the suit basically is something that brings with you a little bit of the environment of the Earth, and so he's very happy there with his spacesuit. As we move forward, for the experimental aircraft, the X-15 that you can see here in the museum, there were the development of X-15 specific suits for high altitude, because this airplane was going up to 100 kilometers, 300,000 feet. So you need a real suit that will protect you fully, as what is called a full pressure suit. And of course, we have Joe Kittinger flight in 1960, and then the silver-looking Mercury suits. Of course, that suit pressurized looks way less cool than it does in the left, but you won't see many pictures of the pressurized Mercury suit. And in April 12, 1961, you have the Yuri Gagarin flight with the spacesuit SK-1, which was the first time that operational suit was used in space. And then a few years later, 1965, Alexei Leonov became the first human to perform a spacewalk, which in our jargon is called EVA, extravehicular activity. Just a few weeks later, Ed White in the Gemini spacecraft becomes the first American to perform a spacewalk on extravehicular activity, and we see this. I'm sure you have seen these amazing pictures before. And then President Kennedy announces well, before that, of course, but it was in '61, he announced the decision to go to the moon. So a lot of people start thinking about the best ways to bring humans to the moon and the best way to design a suit for the moon. So there were all sorts of interesting ideas, some of them more or less comfortable. This one is my favorite for the moon. This was 1962 or 63. The good thing is that you can actually, as you can see here, you can sit inside the suit and eat a sandwich on it. And these were, these were designs of people who thought that at that time that was a good idea, of course. And I kind of love this video. I have to show you these. These are some early design. Well, actually, this is 1964 of an idea, because the scientists at that time didn't know how firm the moon was. This is a kind of a bubble suit. So if the soil was not firm enough, you can just bounce around the moon. And anyway, it's, we look at this now, and it looks pretty ridiculous. But at that time, nobody knew. So this was worth trying what was going to be the best way. And this is another example of a very weird-looking suit. It's just like they call it the wheel suit, and actually it's just that. It's a wheel that moves with the astronaut inside. All right. So, well, you tell me. And in case you find any lake on the moon, you can also. And there were other concepts like the mechanical counterpressure suit, which I think they show some promise. We may not see that in anytime soon, but are supposedly very mobile suits. And the problem that they have is it's very difficult to put it on, as you can tell there with the poor guy trying to struggle to. But we had those cool-looking suits going to the moon in July of 1969, and otherwise we'll have those other suits that we saw in all the famous pictures. So this was a very useful suit, a suit that was developed in a very short period of time and with relatively little money, and it worked very well on the moon. And what I wanted to show you is that you can tell that the Apollo A7L spacesuit and the shuttle spacesuit are related, are very similar, even the portable life support system. So all the development done during the Apollo years serves even today for the shuttle EME suits. And you can imagine all the work on the construction of space station and all that was possible with these very highly mobile spacesuits. Of course, those are not the only operational suits right now. We have the launch and entry suits that were used in the shuttle until very recently, that came as a spin-off of the military from the SR-71 program. And NASA, in the part of the 80s and 90s, started looking at the possibility of high-pressure suits, because the spacesuits are pressured at normally 4.5 psi, not more, and they use pure oxygen. So in the planning of the Space Station Freedom, there were the talk of having a 14.7 1 atmospheric pressure inside the suit, and in order to do a EVA, a spacewalk, you have to go through a process called pre-breathing, that is to eliminate the nitrogen from your body. So it's very time-consuming. So NASA came out with this idea, which finally was not used. And of course, lately, we have been working in what is the private space flight suits that probably some companies will be using soon. So there have been a trend of evolution in spacesuit development from the American and the Russian side. This is in Zvezda, in the Russian factory of spacesuits, and they are testing a planetary suit that they developed a few years ago, based on their Orlan design. But of course, we know that at the end, the objective that many of us have in our minds is Mars, and hoping that in the future we'll have a sound program to go there. The researchers have been looking for ways to develop a spacesuit for Mars based on the lessons that we got from Apollo, which is the closest we got to a planetary surface. So these are some of the differences that you have between a zero-G suit, a suit for space, and a planetary suit. And some of them are, well, the weight. In the case of Mars, you have 1/3 of the gravity of the Earth, so you have to develop a suit that is not 300 pounds, because on Mars you will have to carry 100 pounds with you all the time. So one of the goals is to make it lightweight. Good lower torso mobility, that you can be able to walk and do the things that you're supposed to do on Earth. Dust, contamination control is very important, something that you don't have to deal in space. A different thermal scenario, center of gravity, and other things. So these are mainly some of the things that you will do on a planetary surface: to reach an habitat, deploy systems, excavate, do science, explore, etc. So you have to make a list of all those things in order to develop a suit that will accommodate to that particular environment. So in the university where I work, we have been working for 7 years in developing of planetary spacesuits, surface spacesuits. So these are just some of them. This is the NDX-1, and you can see that that brown kind of tiger-looking suit there actually is the same one of, you can see the blue one. The thing is, the blue one is the outer garment that we have for that suit, but it's actually the same suit. It's a high mobility suit that we developed for, well, actually it was developed for the Mars environment. And we learned a lot from Apollo because we were able to see how much the fibers are damaged by just a few hours on the environment of the moon. So you can see over there in the microscope a little bit of fabric of an Apollo suit. You can see the erosion that the lunar dust creates in the fabric. And we have been doing, along with NASA Ames, NASA Ames Center in California, some testing on one of their tunnels about, you know, Mars, you have wind, and you have a wind dust devil, so we wanted to see what will happen to the fabric. So we got a lot of information and ways of how to protect the suits and the fabrics for future planetary exploration, because, you know, one day we'll go to Mars, we'll be months in there. It won't be just a few hours or a couple of days like in the moon. It took us so long to get there that we'd rather stay, right? So we need a suit that will withstand the dust. And this is another prototype, the NDX-2, which is a rear entry suit. As you can see here, it's like some of the designs NASA is looking right now. And as part of the grant that Dr. Lewis was mentioning, we are building an inflatable or expandable habitat that we are building right now, and will allow us to interconnect several of them and do some what is called analog testing. Since we are not going to the moon or to Mars anytime soon, we'll have to learn here to do as much as we can with the tools that we have. So one of the goals is to develop this prototype habitat and learn from it about how we are going to do operations on the moon or Mars. So I'm sorry about the drawing. It's a kind of it looks like a toy, like a Playmobil toy, but we are building this pressurized rover right now with 2 suit ports that will be compatible with our suits. Actually, you can see it there. It's still in the works, so many things have to be replaced. We'll have 2 suits hanging on the back, and it's kind of all-terrain wheels. But basically, we'll have this ready by the end of next year, and we'll be working with NASA scientists on how to deploy it in different analog scenarios to try to learn more about how you will conduct operations on a planetary surface. And this is mainly just some of the pictures of the frame, that frame that you saw in the other pictures that we just received a few weeks ago. So we are working in the inside. It's a lot of fun, and we have the chance to teach the students how to do these operations for, you know, in the future they may be working for NASA or for NASA contractors, so they may be able to come up with this kind of work. So I guess my time is out, so I won't tell you some of the other things I was going to tell you, but it doesn't matter. We will have time later. I do believe that we have most of the technology to at least from the spacesuit point of view, to develop a suit that will be operational on Mars. I'm very confident that in 3-4 years we can have a fully operational suit for Mars, and it will be way better than the ones used during Apollo, because we have different materials and more experience and etc. So I don't see, at least from that point of view, any problem on accompanying the technology on advanced spacesuits to accomplish advanced exploration to Mars. And that's it. Thank you very much.